All right, so beginning with our second unit in CP Chemistry, this will be our first lecture. And with this new unit, we are going to begin by delving into how we classify matter in the world of chemistry. All right. So we'll begin by talking about what matter is, defining what we mean when we say matter. All right. So textbook definition here is anything with mass that also takes up space, right? Which is basically everything that exists except energy, all right? And all matter is composed of little tiny particles we call atoms. Those are things that we will talk about in more detail a little later, all right? So anything that takes up space and has mass is considered matter. All right, so as you guys will see in the ChemQuest, we're differentiating matter initially. So our first kind of two main categories are what we call pure substances or mixtures. And so we'll spend a little time talking about the difference between a pure substance and a mixture first so that we can better understand the next level of classification. So a pure substance is composed of a single material, all right? And so when we say a single material, we're talking about a uniform material. So for example, carbon dioxide. Now carbon dioxide, or CO2, as you guys will notice, is composed of both carbon and oxygen. So you may be wondering then, why is that a pure substance? That looks like two substances, all right? But in this case, we have carbon atoms bonded to oxygen atoms. And so by bonding those chemically, what we're creating is a single material, even though it's composed of two different elements. All right? Water, similar thing. H2O, which is hydrogen and oxygen atoms, because they're bonded chemically, they no longer retain the properties of hydrogen or oxygen separately. It creates a new material that is also a pure substance. And of course, gold and carbon, gold being Au, and carbon, just letter C there on the periodic table, are elements, and of course only made of one type of atom. Alright, so pure substances can either be elements or compounds. So elements, again, this would be like the example on the last page, carbon or gold, whereas compounds are two or more elements chemically bonded. Alright, so elements cannot be broken down into a simpler material. So gold is just gold atoms, carbon, just carbon atoms, nitrogen is just nitrogen atoms, right? And those are what we find on our periodic table. There's a whole big list of them, all right? So elements are pure substances. Compounds, also considered pure substances, except they are composed of two or more elements. Now, we could have more than two, by the way. We'll see some examples of that some other time. But salt, for example, is composed of sodium and chlorine ions that are chemically bonded. Now, sodium is a really soft metal. You can actually cut it with a butter knife. Really, really reactive with things like water. Right? Chlorine, chlorine gas at least, it is a gas and it has some disinfecting properties, and you don't want to breathe that stuff in. But when we bond those chemically to make sodium chloride, we're no longer retaining the properties of the sodium or the properties of the chlorine by itself. We're creating a new material that is its own material. All right? And because it's a single material now, we still call it a pure substance. And of course, water is that example we already went over. Okay? So pure substances can either be elements or compounds. Elements are made of a single type of atom. Compounds are two or more elements chemically bonded, okay? And when they bond, they produce a new material with its own unique properties, okay? Now, in our world of matter, so there's our pure substances, elements, and compounds. We also have what are called mixtures, okay? And so with our mixtures, we have kind of different types. So a mixture would be composed of two or more pure substances that are not chemically bonded. And mixtures can end up being what we call homogeneous or heterogeneous. So now we'll talk about mixtures. So So if it's a mixture, again, mixture is two or more pure substances that are not chemically bonded. All right? So if I were to take sodium chloride and add it to water, so sodium chloride, pure substance, water, pure substance. If I put them together, we're not going to get a chemical reaction that actually bonds the sodium to something else, right? Or the chlorine to something else. The sodium chloride and the water will remain separate materials. They will just mix together into what's called a homogeneous mixture. All right? So we have two pure substances that do not bond chemically. Okay? Two or more pure substances, and that makes a mixture. All right? So if it's a homogeneous mixture, it looks like a single material, even though it's not. Okay? So we can have water or salt water or sugar water. Okay? So pure water is a pure substance, right? It's just water. Now salt water would look as if I had a glass of salt water and a glass of pure water in front of you. They would look the same. If I had a third glass of sugar water, all three glasses would look nearly identical. All right? And that's because, I should say one phase, not on phase. Excuse me. All right, so one phase. So the phase in a mixture is referring to the visibly distinct parts of a mixture, right? And so homogeneous mixtures like salt water or sugar water have a single phase. You can't see the individual parts. You see the liquid, and there's salt or sugar mixed in, but you wouldn't be able to see the little particles of salt or sugar that have dissolved in the water, right? So it looks like a single material, but is not. Heterogeneous mixtures, on the other hand, you can actually see the individual parts. All right. So let me think of an example. Let's say I have vanilla ice cream. Okay. Now, so not vanilla bean where you see the little flecks of vanilla in there. So I'm just talking like probably the cheap kind of vanilla ice cream where you just see this white ice cream, right? So there's sugar, there's vanilla, there's cream, there's milk, right? And it's all mixed together. There's probably some water in there. It's all mixed together. Now, you can't see the sugar or the cream or the vanilla. It looks like a single material. Now, if I put M&Ms into the ice cream, right? I would then be able to see the vanilla ice cream. And it's separate from the vanilla ice cream, I would be able to see the individual M&Ms, right? By adding those M&Ms, I then make it a heterogeneous. Okay? So that's where you can see the individual parts. You can see more than one material as part of that mixture. All right? So within mixtures, we refer to things called phases, and we refer to things called states, and we got to make sure we understand the difference between those. So a phase, right, as we just talked about, is the individually distinct or the visibly distinct parts of the mixture. All right. If it's a single phase, we know it's homogeneous. If there's more than one phase, we know it's heterogeneous. Now, a state, though, is referring to the states of matter, like solid, liquid, gas. So again, if I am referring to something like salt water, right, I am talking about a mixture of salt and water, right? It'd have a single phase because we wouldn't be able to see the salt being dissolved in the water. But salt, as we know, is a solid, and therefore we would end up with two states of matter. So phase is referring to the visibly distinct parts. State are the individual solid, liquid, gases.